There we go. I think it's something like I have to initiate the stream on YouTube first, like I have to load up the page or something, and then I can start streaming it. I don't know, it's something weird. Anyway, all right. So what was I working on? Right, I wanted to, not model manager, memory manager. I want to delete this whole class. And to do that, I'm using it in swap chain. So I have the swap chain color image, depth image, story image view. Yeah, so I just need to fix the color and depth stuff, and that's it. So yeah, let me go here. So device memory, yeah, none of this I actually need anymore. Depth format, I guess I'll keep that. Don't need this, don't need this, and these are just going to be images. VK image view, depth image view. Okay. Turn depth image. Oh, these need to be pointers. Unknown type name image. There we go. Depth image view, depth image dot, or, okay, I need to have stuff in here for like image view and all that. So let's go to, or actually no, it's image view is image info dot image view. There we go. And the image itself is depth image. Let's just do VK image. Okay, depth image, color image. Okay. And swap chain. So color image. So get rid of this. Right. And now, oh, now this is just color image equals new image, and I need all the parameters. So let's grab this. I don't know why it's not showing me the constructor, but whatever. All right, so format is surface format. Surface format, number of samples, I guess that's one, or no, it's MSAA samples. MSAA samples, I think so. Let me see what the memory manager. Okay, width, height. Let me just do it like this. There we go. All right, so yeah, that's sample count flag bits. Tiling, that is tiling optimal. Image usage flags is transient attachment and color bit. Memory property flags is device local. Image aspect, that should be from here. It's color. Okay, image aspect color bit. Width is extent width. Height. Extent height. And then MIP levels is 1, I would assume. Yep. There we go. And then do the same thing for depth. So yeah, just copy paste this. And then this is depth image. So instead of surface format, this is depth format. MSA samples, tiling, optimal. This is just stencil attachment, depth stencil. Let's see how this is doing. Yeah, Twitch shows unstable, but OBS shows 0 drop frames, so I don't know what's going on there. YouTube's saying something similar. Or no, it's just higher than recommended, but not that I've dropped frames. Strange. It might not like variable bitrate or something. I don't know. Anyway. Yep. So depth image, tiling optimal, depth stencil. Yeah, device local, color aspect. It's probably not color aspect. Yeah, it's image aspect, depth bits. And then what else does it say down here? That's it. Or no. Hold on. Yeah, that's it. Then I can get rid of this window. There we go. So depth image equals new image. Yep, that's good. And then just delete these. Delete color image. Delete depth image. Get rid of memory manager. Okay, now I think I can just delete the class. Right? Or is it in common? There's somewhere that I'm actually storing. I have like an external variable somewhere. Just not sure where. So I thought in here, yeah, so this is like VMA static Vulkan function. So I need to put VMA implementation somewhere else. Probably just in device, I guess. Or am I using VMA in here? I guess not. I mean, this is VMA Vulkan functions. Yeah, whatever. I'll just do this in here. Device. Yeah, VKMM alloc. Okay, so that should be fine. Okay. Yeah, and then here's this. So I should just be able to delete these files. Memory manager. And then delete memory manager. Okay. Let's see how this works. So included a bunch of places. Global CPPN. Okay. Oh, yeah. That makes sense. Okay, where else? Let's see it. Pipeline. Model manager, model. Oh, memory. Oh, I was doing this global memory manager. I thought I was doing this in model manager. Oh, I see. Okay, well, all right. Then what I'm going to do is I'm going to add the swap chain changes, but I'm not going to do everything else. So add swap chain, add that. Let's commit. Don't use manager in swap chain. Okay, and then I can just reset. There we go. And this should work. Oh, no. Right, I need to add VK image to image. actually, VK image view, I think I don't. Yeah, I can just put it straight in image info. Info.image view. I'm gonna get rid of that. Make sure this all works. There we go. Okay. So then this should just be, yep. Get status. Yep. Move redundant image view. Okay. And then in Memory Manager, so I don't need create or delete image or any of this, but I still need to somehow keep track of these global image infos. So, yeah. Yeah, I can get rid of all of this stuff. I don't even need the constructors anymore. Or, okay, I do need the constructor at least, not the destructor. Get rid of this, and get rid of all of this. No member name memory manager. Oh, I got rid of too much. Everything except that. Here we go. It's definitely an improvement. I don't need this, don't need this. Don't need this. Do need these, don't need this. Oh, I do need Vulkan. There we go. LD failed. Undefined reference. Hold on. Device. I think I just need to include this. Oh, I forgot that. Yeah, that's fine. Okay. I thought it. Yeah, when I undid the commit, got rid of that. Let's see. Rewrite. Renderer, Vulkan, memory manager, CPP. Here we go. Just need these. That should fix it. No. Okay. This probably has to be above here. Yeah. Since I'm including VK memmalloc in device, so it probably has to be above device so they get defined first and all that. Here we go. Okay. Yep. Remove memory manager image handling. Okay. So there we go. And then, so one thing I do want to do, I'll get rid of this entirely when I want to make a descriptor manager class. Maybe I'll just rename this one. I don't know. But I do need to do a descriptor manager class before I do compute shaders, because like currently this is like global image infos and global buffers, and so I don't actually have a way to like easily do this per pipeline, and so like the compute shader would have different pipeline. So I need to have like support for only like rebinding the needed things first, and so I would need the I'm going to do that through like another descriptor manager class. That seems like the best way to do it, and just pull all this stuff out of pipeline. Since it really shouldn't be here anyway, it's just where it ended up. Okay. Let me see what else is on my list, because I think I had some stuff I wanted to do before that. Yeah, so I can add like normal maps and all of that. And then I can add swap chain recreation with whatever. Yeah, and then I have like textures not getting deleted with add and remove. Yeah, I guess fixing descriptors is probably the most, like the biggest thing to do right now. And then everything else is kind of secondary. So I'll start working on this. But there is one thing I want to. Where was it? It's in Model Manager. Yeah. So I have like samplers here, base textures, and then I have where is it? Render graph, I think. No, it's renderer. And then here it's like vertex buffer, index buffer, instances, indirect commands. So all of this, these are like fixed constant names that have to be there for everything to work. And I'd rather put all these names in like one file somewhere, and then just reference them, since like that's what I need. The like the shaders need to have these in them if they want to work properly. And so I'd rather have that like simply like have it defined somewhere rather than having it kind of scattered around the code. But I guess before I guess I probably should just put that in the descriptor manager class. Yeah. Yeah, so really I just need to start with that. Okay. Then let's just make a new class. New file. What is it? I forget how to make new files. It's been a while. No. Space. No, it's buffer new. How did I forget how to make new files like that? I can do it like this. Space CF. Okay, create file. I'm gonna call this descriptor manager. Okay. And then, oh right, it's just like this. Then I can do descriptor manager HPP, I think. Yeah, and it makes me a new file. Yeah, that's how it works. Okay. So class descriptor manager. Private. Okay. So So when I'm going through the shaders, right, I'm doing this pipeline descriptor layout, add sampler, add binding. Yep. So this is how I'm registering what descriptors I need for the shader. So, and I need that before I create the pipeline, right? Yeah, because I have to have that descriptor layout. What is it? Yeah, it's right here. So when I'm making these shaders, I pass in this pipeline descriptor layout, and then so then the shaders add whatever things I need to it. And then I go here and I create the layouts, and then, yeah, then I make the pipeline with and all that. So I think that part is fine, except there is this issue, this here, about like the descriptor count. So would I have to recreate the pipeline whenever I make new descriptor counts, there might be some kind of like what is it? Update after bind? No, that's not it. There's probably something in Vulkan for like editing the layout after the pipeline already exists. Maybe. Let's see. Let's just start with like what is it? Like VK descriptor layout something. What's this here? Okay, well that's my own descriptor layout. Where is VK descriptor set layout binding? Okay. Set layout binding. Yeah, descriptor type, descriptor count, number of descriptors, accessed as an array, except if type is inline uniform block, the size in bytes, 0. This binding entry is reserved and the resource must not be accessed from any stage. Okay. Description. Yeah, it could be sparse, that's fine. Let's look at pipeline. So it's just like create pipeline. Graphics pipeline create info. Yeah, so pipeline layout. Okay, 0 more descriptor set layouts, 0 more push constants. Pipeline layout. Is there a way to like set offsets, set buffer info? Like, I think I can do this with descriptor buffers, maybe? Maybe not. Yeah, I'm trying to figure out a nice way to handle setting these dynamically whenever I'm like adding and removing images. Now, like I can allocate it in blocks and stuff, but still, if I go over the box size, I need to make it bigger. And I'd like to do that without rebuilding all the pipelines, since I need this to be set before I make the pipeline. And so I'm trying to see if I can like update the pipeline layout, at least like the descriptors. Maybe there's like an extension for it or something after I create the pipeline, but without like recompiling the shaders and all that, because I don't need to, since that I'm just trying to reserve more space for the array. Like, so yeah, it probably works with descriptor buffers. Let me see. Would that get descriptor layout size? Well, maybe not, because like I still have to make the pipeline with a certain layout. Yeah. Like even though I'm using descriptor buffers, it still has the same layout. Descriptor update template create info. What is this? Newly created update template. Can be used to update descriptor sets with a fixed layout. Set to push descriptors. Descriptor set layout used to build update template. Pipeline bind point. Parameters ignored. It's not push descriptors. Just tell me what this is actually for. Like what uses this? Okay, create pipeline layout. Here we go. And then create info. So number of descriptor sets, pointer to an array. Vulkan update pipeline layout without recreating pipeline. I don't even know if this is possible. I know there's something about like Vulkan shader objects. Maybe I could do this instead of pipelines. KEXT shader object. Lighter interface. Okay. Pipelines require every desired combination of shaders, all stages using monolithic pipelines to be compiled together, whereas shader objects allow stages to be compiled in arbitrary combinations. Okay, maybe I should just switch to this anyway. Pipelines linking is an explicit step. Shader objects linking is simply a compile time promise from the application. We'll always use certain combinations of shader objects together. This must always be linked before use. Shader linking is optional. Implementations to require some state at compile time. All state is set dynamically and is independent from shaders. So this kind of sounds like what I want. Requiring rendering attachment formats. Shader objects don't. Pipelines compiled. Code can be, retrieved and used by the application form of pipeline cache, but the state is not usable to create new pipelines. Shader objects compiled shader code can be retrieved directly from any shader object. It's guaranteed to create an equivalent shader object. Okay. So I'd have to implement my own shader pipeline caching thing, or just shader caching, since with pipelines, like it handles it for you. You just read and write to a file. So to do it myself, and I don't know if on any compatible physical device. That's the promise. I don't know if there's like a good way to figure that out, because I know Vulkan will do it for you with the pipeline cache, but I don't know if it works like that. But anyway. VK create shaders. Next stage. Code type, code size. Okay, but you still need. I still have to give it a set layout. So this doesn't actually solve my problem. So, yeah, I mean, this might just not be possible. I might have to recreate the pipelines. I like Vulkan update descriptor count after pipeline creation. Variable size descriptor bindings. Runtime descriptor arrays. Oh, maybe this is what I need. Not LOVM. Comes from the size specified by the descriptor set length. Yeah, I already have this. Unbounded array to stream in textures. Vulkan has a restriction that unbounded array must be the last descriptor in the set. To do this, the structure in your pnex chain has an array of flags. Any descriptors which can be an unbounded array must have the flag. Descriptor binding variable descriptor count bit. Okay. So this looks like what I want. For example, if binding 3 is an unbounded array, then must have, descriptor count member out the descriptor set. Layout binding is an upper bound on the size of the array. Is it truly unbounded? Okay. That seems kind of pointless then. You must use set variable descriptor count allocate info. Descriptor counts of each set with variable descriptor count. Maximum number of each in your unbounded arrays. This will be the last binding. There can only be one unbounded. Yeah, okay, this isn't going to work for me. I'm actually going to have to recreate my pipelines then, whenever I change stuff. That's very annoying. If I'm using like more than the max. Because like the thing is, I could, what is it? In here. Right. So like I could make descriptor count like 1,000 or something, but then like I'm wasting a whole bunch of memory that I'd rather not waste. Now it should just be like, it's a descriptor, so it's probably just like a pointer anyway, but still I'd rather avoid that if I can. But it looks like even if I use unbounded descriptor arrays, there's still the or runtime descriptor arrays or whatever. It says I still have to put an upper bound on it, which seems like what's the point? Especially if it's like pre-allocating it, then I don't even see why this exists in the first place. So I must be getting something wrong. Yeah, it's an upper bound. It's a truly unbound. So partially populated descriptors. I'm already doing that, but it's not complaining. Creating descriptor sets. You must use VK descriptor set variable descriptor count. Struct to tell Vulkan the descriptor counts of each set with a variable descriptor count. Okay, I'm actually going to be right back. I got So, look up, partially bound runtime descriptor. Am I already using that? Let me look at my features. Runtime. Yeah, I'm already using runtime descriptor arrays. Yeah. Okay. Finding variable descriptor count. Okay. Note on descriptor indexing. So, yeah, array textures. Yeah, I want array of textures. Yep. Texture binding. Mask approach, a bunch of textures. Yep. For that context, your shader needs to select a different texture at runtime depending on some arbitrary data that's not constant. Onion textures make it easy since it works out of the box, since you can just use the Z component of the coordinates. On the other hand, Vulkan doesn't even guarantee you can dynamically index into an array of textures at all. Yep. Two features you can enable that relate to support for using arrays of textures and shaders. Fortunately, explanations are somewhat fuzzy. Yep. Okay, so nothing. Indexes into texture arrays need to be compile time constants. Okay, enabling sampled image array dynamic indexing. You can index into your texture arrays with whatever you want. It can be dynamic, but it has to be uniform across the draw call. It has to be the same for all shader invocations, otherwise it's undefined. Indexes can be dynamically non-uniform. Yeah, so this is what I'm doing now. They can freely diverge. This means I can use whatever I want. Yep, I'm doing this. Yep. Help you avoid things. Yep. Tier 2 is the real deal. Yeah, non-uniform descriptor indexing. Yep. Yeah, great. Descriptors not supported everywhere. Orca Mobile, Skylake, whatever. Might be marginally slower. Yeah, probably doesn't really matter. Renderock supports it. Okay. Okay, but this is just the GLSL side. What I want is to change the descriptor count without rebuilding the pipeline. I just want to like hand it a new descriptor layout. Just be like, oh yeah, I'll update it, fine. And not have to like recompile everything. Which I can let it like recompile the pipeline, but I don't know, like maybe I could allocate like 1,000 descriptors at a time or something. And then if you ever need more than that, then I can just like double the size, something like that. Or maybe start with 10 and just double the size from there. Maybe not 10. Let's start with like a power 2, so 8. 8 or 16 or something. And just keep doubling it, which is fine, but I still have to recreate the whole pipeline, which I'd rather not do. And then like I also have to manage the sets themselves, right? Because this has a count here. This is why descriptor buffers actually make this a bit easier. But yeah, because you don't have to worry about like set allocation or anything. You just allocate one big buffer and then you put all your descriptors in there, and then you're fine. Um, hmm. Which, I mean, I guess that's why it has to have like a fixed size. Yeah, and so it seems like, yeah, when one of your descriptors is an unbounded array, yeah, so like any number of textures, descriptor count member of the layout binding is an upper bound on the size of the array. Yeah, so like it's just allocating the whole block anyway. Oh, hey, you're back. Um, I'm right now. I'm thinking about how I'm going to redo my descriptor system. So, because like right now, every frame I'm like updating every descriptor set, and then but and also this like only works for having like one pipeline. But if I want multiple pipelines, like compute shades and things like that, then this isn't going to work for me. And so I'm looking through like the Vulkan spec and some other stuff about trying to figure out how the these descriptor counts. I want to see if I can set these dynamically or if I need to like recreate the pipeline every time. Oh, and then how I fixed that crash yesterday was something really stupid. Where is it? Yeah, in pipeline. So if you look down here, so this now says if not use descriptor buffers, then update descriptor sets. What this said before was if use descriptor buffers, then update the descriptor sets. And so what was happening was this was never running because I'm not using descriptor buffers because RenderDog doesn't support it. And neither does my driver. But anyway, yep. So I was never updating the descriptor sets, and then that was like completely crashing my GPU because in the vertex shader here, I was never setting the descriptors or anything, and then so I'd go and I'd try to do all these levels of indirection to try to pull some data out, and I basically just had a whole bunch of like null pointer dereferences and stuff like that. Yeah, it was literally one character away. I spent like an hour on it or something. Yeah. Anyway, yeah. Oh, and then I got all the textures and stuff working earlier today or last night or whatever. So now, so yeah, I've got this little sample texture right here. Yeah, and then I think I showed you the engine on like an old commit. So yeah, everything is working right now. And I just did some little things this morning. I in my image class, I just split some of this stuff out. So now I have like image and I have texture. And that just helped me kind of clean up some stuff. So now like specifically in the swap chain here, now I just have like color image and depth image, and I can just make new images that don't have like an actual texture associated with them. But anyway, yeah, right now I'm trying to plan out how I want to redo the descriptors. And so what I was just talking about, the main problem is that in here, so for these arrays, like the samplers and the base textures, right? These descriptor arrays, then I have to have a fixed size here in the layout binding, which makes sense because like Vulkan needs to know how many, like a descriptor is basically like a GPU pointer, and so this is like an array of pointers, and so Vulkan needs to know how many pointers, how much space in that array to actually allocate me, which makes perfect sense. But then the problem is it's not trivial to like update this number later on because I basically have to recreate the whole pipeline because the pipeline you need the pipeline layout. Yep. So you need the pipeline layout, and that pipeline layout depends on these descriptor set layouts, right? And so I could do something where so that like the only real solution I can kind of come up with right now is that I can just start off like creating a like a power of 2 for descriptor count for images and samplers. And then whenever I need to add more, I can just like multiply it by 2. But then I have to recreate the whole pipeline, and then I can use the new size, which just seems kind of stupid to me. But there doesn't seem to be a way around it, because like I'm just changing the size of the descriptor array, so I shouldn't need to. But I'm gonna have to like recompile the shaders and all of that, and like everything else that goes along with the pipeline, when I just need to make the array a little bigger. And I'm trying to see. I don't think it would even work with descriptor buffers either, because with descriptor buffers, I don't know how much you know about it, but like instead of doing the descriptor sets and the descriptor pool and all that, or at least kind of have sets, but you don't have the pool anymore. You just kind of allocate everything yourself into one big buffer. But still, it looks like I have to give a fixed layout size. Yeah, redoing the pipeline is like completely redundant. That's what I'm trying to do here. There's this guy. He wrote an engine, and he's talking about like this exact problem of how he's managing like unbounded descriptors and things like that. Yep. But he's still saying that like you have this descriptor count is still an upper bound on the size of the array. So this doesn't actually change anything for me, because I can't just update the descriptor count after the pipeline's already been created. The rest of this is just for like partially updating descriptors, which is fine. But I'm not sure if I even need this, like this partially bound bit. I'm not sure, because like I have descriptor count 5 in here. Oh, but yeah, but then I'm only binding like I'm already kind of doing that. And then in here, like the size is only the size of these image infos. But I'm not using oh, where did that window go? There it is. I'm not using partially bound bit, but I'm not getting a validation error, and everything's working fine, so I don't know. Maybe I need it, maybe I don't. But anyway. Yeah, and so I think I have to recreate the pipeline. I can't just update pipeline layout. Or unless there's Vulkan update pipeline layout. Yeah, descriptor set layouts. Describe a list of descriptor sets. You need one layout binding for each descriptor set. Yeah. You have one descriptor, which is indicated. Yeah, and then you create the set layout, and then the pipeline layout contains a list of set layouts. Just defining the layout. Actual descriptor set is allocated and filled in. Shader referencing. Yeah. Because it seems like I don't think there's a technical reason why it can't just why this doesn't work. Like I think I could probably get away with it with using descriptor buffers, because I can just kind of ignore the max size here for the descriptor count, and I can just still like allocate a bigger buffer and index into the buffer. So I think with descriptor buffers it's fine, but then like the descriptor buffers isn't well supported, so I don't want to use it. That's why I have those flags for disabling it. What's the GLSL extension again? Non-uniform qualifier. Okay. But then in here, he was saying, yeah, write 2 textures to this descriptor. Yeah, like this is already what I'm doing. Let's see, Vulkan, runtime descriptor array. think about build systems. For C++, I've really only used CMake and like make files, and CMake works, but it's still pretty bad. And I just have my make file with these commands to like help me use CMake. Yeah, Rust build system is a lot better. But I'm kind of just making do with this. But yeah, I don't really know all that much about it, like about specific build system. Like it took me a while to, and even like the CMake documentation is really bad. Like there's a lot of, it can just be very vague at times. Like differences between like target include directories and add subdirectories and yeah, pre-make most new friendly clean Lewis syntax. Okay, yeah, maybe I can check out pre-make, but got CMake working now, and I kind of know how to use it. CMake docs are horrible. Yeah. Yeah, so getting back to this. So I guess for right now, I'm probably just going to, start off with like a default descriptor count of like 8 or something, and then just keep increasing it, and then I'll have to rebuild the pipeline whenever whenever I need to allocate more, because I don't think there's really a good way to do this unless I can find something in this documentation here. So update after bind, create descriptor set, and update it with all the descriptors after a set is bound. Cannot be updated again. Yeah, no, this is not what I want. Update unused while pending, partially bound, variable descriptor count. Different levels of indexing resources. Dynamic indexing. Next must be dynamically uniform. Yeah, non-uniform indexing. Yeah, so this is what I'm doing right now. And this is fine on the GLSL end. But then I'm not sure if Vulkan actually supports like updating the layout. Yep, subgroups. Yep. Left side. Yeah, where's your dog? There's nothing in here about like actually updating the descriptor array count after I create the pipeline. All right, well, for now, I'm just going to recreate the pipeline. It kind of sucks, but it's not really a better way to do it. Or actually, really, for as of right now, I'm just going to set these to like 1,000 and not care. Or whatever, I'll leave it at 5. I will figure this out later. For now, really, I want to get the, I want to move this update descriptor stuff out of pipeline and into this descriptor manager, so that I can actually have like multiple pipelines and only update the needed descriptors. And then later on, when I need to add new, when you increase the size of the descriptor array, then I can figure that out. I'll probably have to recompile everything, but okay. So yeah, I have these descriptor rights. And so if I want to only rebind the needed sets, then basically all I really need to do is just, it's like this VK update descriptor sets. Yeah, this just takes a whole bunch of descriptor rights, right? And so like one of the reasons I might need to update a descriptor is with my, where is it? Yeah, so this is like my GPU memory allocation library. So one thing I can do is I can reallocate the buffers. So like if I try to add an object, and it needs to add a model matrix, and I don't have enough space in the buffer for the model matrix, then I can just uh, recreate the buffer and then add it. But then that changes the actual like VK buffer handle. And so what I needed, when that happens, what I would need to do is go in here into update descriptors and then reset the handle. Where is it? Right here. This is where I'm getting the handle. So what I could do is I could hook into this realloc here, and then whenever this gets reallocated, or yeah, like whenever this buffer, the VK buffer variable changes is really what I want, then I would create a descriptor, right? Yeah, I think what I would do is I would talk to the descriptor manager and I would say, hey, I'm this GPU buffer named whatever, because I have like, I have names everywhere for like tracking objects, right? So I like this name here. I can say, hey, I'm named this and I just created a new buffer. I recreated myself. And so now you need to go and update all the descriptors that depend on me with this new buffer. So that'll work. So, okay, so then in descriptor manager, so I'm going to need to keep track of, at the very least, I'm going to need to keep track of probably just a queue of descriptor rights. Or do I want to use a queue? No. This has to be a vector of descriptor rights. VK descriptor right. And you guys have any questions about what I'm doing, you can just ask. But anyway, descriptor rights, VK right descriptor set. That's what it is. VK right descriptor set. And this is going to be, yeah, just descriptor rights is fine. Okay. And then so now I have this descriptor right. And yeah, I don't want to create the descriptor right in allocator. Text is pretty small. Oh, yeah, I actually have an ultra wide monitor, and then I've just like cropped it down to 1440p. But I can zoom in a little bit. Is this any better? And then I think Twitch, am I streaming at 1080p? Yeah, and then I'm downscaling to 1080p on Twitch. So yeah, it probably doesn't look great on Twitch. Yeah, okay. Yeah, and so in this GPU allocation, like I don't want the GPU allocation to have to know anything about like what descriptors are actually using it. All I need to do is have like a callback to the descriptor manager and say, hey, generate the descriptor rights and then update me on the next frame or whatever. So then let's go into pipeline here. So descriptor rights, so it's how I'm actually making it. So I'm going over the set layouts, yep, and then the bindings, and then getting the name out of it. Okay. The stream is 1080p. Yeah. Oh, I think. Oh, I'll have to change the size on all the buffers. That's fine. All right. So yeah, descriptor rights pushback. Thinking of how I want to iterate over the needed descriptors. So like, well, what I probably don't want to do is just like loop over every descriptor on every pipeline and then see, do any of these use any of the names that that need to be rebound. It'd be much better if I can just like have a hash set of all of the descriptor bindings. So I probably need to rework how I'm handling these binding layouts and set layouts. Because, yeah, this is a map of integers to bindings. Yeah, and then only here I actually have descriptor name. Is cross-platform something you care about? Yeah, generally cross-platform. I haven't actually tried it on Windows, and I don't know about Mac, because with Mac, one, it's on ARM, but it shouldn't really be a problem because you can just compile it yourself. But then there's also like the Metal to Vulkan stuff, and I don't know how feature-rich the Metal to Vulkan translation layer is, because there might be like, I'm using a whole bunch of extensions and weird things, and so I don't know if Metal supports all of that. And so I think eventually, like, I want it to be working well, like you can work on like mobile or something. But that's, I need to have like a working engine first, and then I can see about, all right, well, how can I simplify this to work on like worse devices? But then I am using GLFW for like the window and all of that, and that should handle like the majority of the actual cross-platform stuff about like getting keyboard input, getting the mouse, getting a window, drawing to the window, all of that stuff. So I shouldn't have to worry too much about like whether or not it works on Windows at least. Yeah, but I just don't know a lot about if it'll work on the Mac. I don't even know if there is GLFW for Mac. I would assume there is, but anyway, make this bigger. So yeah, so if I look, where is it? Yeah, this is where I was. So I probably want to redo how I'm keeping track of these set layouts and binding layouts. I think because what I'm going to want is to have like a hash set of like descriptor name to bindings. Yeah, or I mean, maybe I could keep it like this, but then I could also keep track of the hash set. That's probably another way to do it. Hmm. Hmm. But then now, like, how many descriptors am I really going to have anyway? Like, is it worth doing all that when I could just like even if I have like 100 descriptors, what's that going to take, like half a millisecond or something, or less, maybe a tenth of a millisecond? Yeah. So I think for now, I'm not going to worry about the it being n squared. If that ever becomes a problem, then I can rework this to have like be doing a hash table or something. Okay, then I'm just gonna like copy and paste this pretty much. Actually, just delete it. All right, get it out of there. And go into Scripter Manager. Where did that? Is that? Why did that not copy right? Come on. There we go. So, Scripter Manager updates. Oh. Sahi Linux. Yeah, I saw something about that. Like I know generally Asahi Linux is the trying to get Linux on the ARM, like the Apple M chips. Yeah, it's actual Vulkan driver. Okay. Yeah, so maybe it'll work on there. Yeah, because I know Apple really doesn't want. I don't really know why, but they're like forcing everyone to use Metal. They won't write a Vulkan driver. Just I don't know, whatever. It's just Apple doing that. Okay. So yeah, descriptor layout in set layouts. So I guess maybe so right now the pipeline also owns the yeah. So where is it? Owns the descriptor. Yeah. Yeah, Xbox only DirectX. Yeah. Does it not even have like a Vulkan translation layer or anything? Or you have to do DirectX if you want Xbox? Yep. So right now the pipeline is owning this descriptor layout, which I think is like it's a good place. I think it is right for the pipeline to own it because it actually needs that. Like it's generating that from reading, from like doing shader reflection, and then it needs that to create the pipeline layout. So I think it's fine where to own it. I just need to make sure. Not sure. Okay. Yeah, I need to make sure that the descriptor manager knows all of the current pipelines. It's like, yeah, I could have like a pipeline that I've compiled, but I've just like taken out of the loop. So that means it needs to talk to the render graph and see what are all the active pipelines. And I think, where am I actually like owning the pipelines or keeping track of them? It's in like, yeah, I want to rework how I'm doing a lot of this render graph stuff because right now, yeah, like I'm just making a shared pointer to a pipeline, and then I have this render node which is doing like weird partial application things with Vulkan functions, and I want to rework this, but I guess I won't do that now. But when I do create the pipeline, yeah, I have this shared pointer. So I want to add this to the list of pipelines that the descriptor manager is looking at. IMGUI. Yeah, I haven't set up IMGUI yet just because I've been busy with other things. But yeah, I've heard it's really nice to use. So, yeah, and then how do I want to actually keep track of pipelines? Yeah, I guess just a hash set. And then when I'm I want to, yeah, I think what I want to do is actually in the pipeline, in the constructor here. Yeah, in this pipe. So that should run, right? Because I'm inheriting. Yeah, so I'm inheriting from pipeline. So I think what I want to do is when I create the pipeline, I want to give a shared pointer or just a regular pointer. Yeah, probably just a regular pointer into a hash set that the descriptor manager owns. And then when and so like then I can iterate over all the pipelines when I'm updating the descriptors and see if anything needs to be updated for that pipeline. Because somehow I need to get these descriptor. I'm kind of getting ahead of myself a bit. So I want to start when I realloc the GPU. Then I want to call let me look. Oh, I need to add this to globals. Let's see. Yeah, so it's memory manager, and then I want to say descriptor manager. There we go. And this little globals thing is just how I'm just using this to keep track of stuff I need everywhere instead of having to like include things in a whole bunch of places. Yeah, so descriptor manager, and then, I don't even know if this is actually working right. Really, I think I just need to do, I'm pretty sure I'm not actually using this anywhere, but I'm doing it with the memory manager. I have like a static, yeah. It's, yeah, static memory manager, and then I have this here. Okay, and then I set it to this. All right, so I want to do this stuff, but for the descriptor manager. So let me do this here, and then it's memory manager. This is scriptor. Yep, see ya. Descriptor manager. And then in here, I want a static descriptor manager pointer, descriptor manager. There we go. That should work. Oh, right. And then I need the constructor. Okay. So now that's global. So in here, and follow in learn OpenGL. It's like your many chapters said. Yeah. I like learn OpenGL a lot. Where's it? So like all of the I have a bunch of like PBR lighting code and stuff in here. I just kind of copy pasted from learn OpenGL because it's pretty complicated. So currently I'm actually like rewriting my engine because the old engine, the code down here, it's very static. Like I can't just like dynamically add and remove objects or models at runtime. I have to define everything at compile time. And so right now I'm rewriting everything to work at runtime. So I can just do like add object, remove object. But because I'm using indirect drawing as well, then everything gets really complicated. So that's why I have this whole like memory allocation library. But yeah, I really like learn OpenGL. I learned a whole bunch from this. So realloc. Yep. So I want to talk to the descriptor manager. Descriptor manager. I need to include it. Engine, any specific type of game. I want it to be like at least at first, it'll kind of be like a space themed 4X game. So if you've ever played like Elite Dangerous, or it's X4 Foundations or Avorion, kind of games like that. So you'll like have your spaceship or whatever, and it'll have like shipbuilding stuff. And you go out and you can like whatever mine resources, make a bigger ship, build stations. Yeah, EVE Online, similar kind of thing. Yeah. So that's kind of what it'll be at first, but like I'm making a whole open source engine for it. Oh yeah, that's what I want to do. I think I need to add the GitHub link. Oh no, actually, yeah, in my links somewhere, it should be GitHub for this. So like all this is open source, right? And so eventually I'll probably open it up to like more games. Like, and I'd even want to like add some stuff to it. Like I could also add kind of like Factorio, kind of like factory building stuff. So like you could have like a planet, right? And you want to mine a whole bunch of stuff from the planet. Well, then you have to kind of set up a miniature Factorio system, and like that's how you actually get resources from the planet. But that's kind of far off. I need to get uh, descriptors working right first. So anyway, undeclared identifier descriptor manager. All right, I added it. Why is this not working? Did I mistype something? Descriptor manager, static pointer. This is public. This is how it worked for the other ones. Or memory manager. Yeah. I don't know. It's just being weird. Because I have it up here. Oh, file not found. Did I mistype it or something? Oh, it's not in the... No, it should be in the build system. Yeah, I'm just doing any HPP. Maybe it'll fix it once I build it. Went with JSON. Yeah, well, I'm using GLTF files, and those are written in JSON. I actually ended up using this time around, I'm using the fast GLTF library instead of this. So like I have my own GLTF parser, but it's just like, it's very like boring, tedious code that I don't want to maintain. And so I'm using fast GLTF instead. So anyway, I think once I like rebuild this, it'll fix it, because it's just like not in the Clang cache or something. Anyway, so descriptor manager, and so what I want to do is say like register invalid, and I want to pass it the name, or the I should have a name somewhere. Yeah, so that'll be like the name of this buffer, which is the same name as the that shows up like here, the buffer name in the shader, since I'm doing shader reflection and reading it. So yeah, so I'm passing it the name, and I'll say, hey, anything that's depending on this buffer is now invalid, and you need to recreate it. And then yeah, and then it can just I'm thinking like if I want to pass this whole allocation to it, or like pass the buffer, but no, I think I'd rather pull it from the object manager or the model manager or whatever, or the somewhere I'm keeping track of all of these. Where am I keeping track of it all? Was where in game engine first version was meant for older. Oh, see this. Yeah, yeah. I'm definitely gonna try using JSON rather than like XML files for defining the actual scenes and all of that. Yeah, see this XML game engine. Oh yeah, it's all in XML. Let's see. Yeah. Anyway, yeah, it's cool. Let's go here. So, okay, yeah. So I have this GPU allocator, and this is how I actually create buffers. Now I think there's like GPU allocator. Is it get buffer? Yeah, it's get buffer. So, oh, and so does this just? So do you just have Pong for this, or do you have? Okay, yeah. So there's games, Pong, Breakout, Space Invaders. Okay. Yeah, this is cool. Anyway, I'm just, yep. There we go. So, globals device, globals memory manager, GPU allocator. So I need to pass this GPU allocator to this descriptor manager whenever I create it. Yeah, and then game engine provides all the functions the game would need. XML files configures them. Yeah. So since the renderer owns this GPU allocator, and I'm going to need this to get the buffers, I'm probably going to want to create the descriptor manager here after this. So I can just say new descriptor manager, and then I can add, yeah, I probably want to give it this GPU allocator. Or actually, let's just there we go. Why are you unknown? Ah, right. Computer allocation, I think. No, I thought that was it. Allocation. No, that's not right. Sub allocator? No. Base allocator. Yeah, it's base allocator. There we go. Yeah. So, sorry, I'm not talking much. Okay. Anyway, I'm just yeah, I'm just setting this up so that I can actually. So how this GPU allocator works is this is keeping track of all the buffers given a string. So I create a buffer and then the buffer name, and then so I can get buffer based on that string. And like I was saying earlier, that string is just the buffer name that I'm getting from the shader reflection. And so right now in Descriptor Manager, I'm just passing it this GPU allocator. And so that way I can, what I can do is have a function here where I can just say like register invalid and give it the name. And then the descriptor manager can just pull that name and get the buffer and know that it has to reset anything that's using that buffer. That has that name. So, yeah, GPU allocator. So I might just need to save this. There we go. And then I also need this register invalid. So void register invalid string descriptor name. And then standard do I want a queue or a vector, or how do I want to do this? I guess this needs to be a hash set then. Or what's called C#, or yeah, it's just a set. Yeah. Standard set of strings called invalid descriptors. Get, can I have include set, there we go. Set of strings. And then, yeah, usually, but I want like fast random access instead of sequential as well. And I hope hash set of set of string actually works as I want it to. I don't know. I would think it does, but we'll see. Yeah. So I want this register invalid. Yeah, let's go ahead and write this. Manager register invalid. Yeah, so descriptor name. So all I really need to do here is just say invalid descriptors, insert descriptor name. Yeah, and then if it already exists, I don't really care. Yep, that's good. And then in here, so I have all this. So let's see, I don't want descriptor rights there. I want it in here in update. So I'm just call that descriptor rights. And then for set layout, so I need to get the pipelines, right? And the pipelines are created. I mean, do I want to do it through pipelines? Yeah, because I'll have to recreate the pipelines. Well, no, I only do that later on. So right now, I need to get these descriptor layouts from somewhere, and they're owned by the pipeline. And so I'm just thinking of how I want to let the descriptor manager know about all the pipelines that exist. So yeah, maybe it is better to get rid of this for loop here and then change these around. Yeah, I think what I want to do, just to start with, is instead of having... So yeah, I have this map of integers to sets, which gives me the set layouts. And then I have a map of integers to binding, which gives me the binding layouts, right? So that's like, if you go here, this is like set 1 binding 0, set 1 binding 1, right? That's all that is. I would like to be able to just have like a hash set that I can go straight to the binding with instead of trying to iterate over everything. But that kind of makes some of the other code complicated. So I don't know if I want to do that. But I still need to figure out... Because if I do that, then it's actually really easy for me to know all the descriptors that exist currently. Because... Well, hold on. But maybe this isn't right. Maybe I want to pass a pipeline into this. Because because I could have pipelines. So this doesn't have syntax highlighting. But for example, this is one of my compute shader pipelines, and it's using like set 0 binding 0 for these draw commands. But then like the vertex shader, it's using like set 0 binding 0 for some global variables, right? And so what I don't want to do is do all of the descriptor updates all at once, because then I have like conflicting set numbers and binding layouts. I need to update them. Yeah, I need to update anything that needs to be updated. So Yeah, it makes it kind of complicated. Because now not only do I need to rebind a descriptor if the buffer changed, but I also need to rebind it if the set layout thing changed. But like if I invalidated set 0 binding 0 for like the fragment shader by so maybe I still just want to rebind everything because that's actually kind of complicated. Right? I could rebind everything that a pipeline uses. Maybe let's just do that for now, and then later on I can do like just needed sets if I really need to. Yeah, so I'm gonna pass in a this is to be a shared pointer since that's how I'm building the pipelines called pipeline. Just want to clear it. Pipeline. There we go. So this should be pipeline descriptor layout set layouts. Okay. So then now I'm just looking at one pipeline and getting all the descriptor names, and then getting all of the sets, all the bindings. And then if buffer exists, otherwise create buffer. And then descriptor layout. So this should be, this might not work because this is gonna complain about like const or something. No. Okay, I would think this would complain about const, but apparently not. Oh, okay, mark the function as const. I'm not sure if it's actually const. Oh, yeah, because this just modifies stuff on the GPU, not the descriptor layout itself, so it's actually fine. It's just a little strange. Okay, and then descriptor buffer infos. Yeah, I just need list. And this, like, I think this is one of the few times you actually do want a list here, because yeah, because basically I don't actually need to access any elements, and I don't need to, well, I don't need to iterate to access any elements. Like I don't need to search for an element or anything. And then I don't need to, but I do need to just hold on to some memory for like the lifetime of this function, right? And so if I'm using this list, right, because it's these VK descriptor buffer info, and this is what the descriptor write. So the descriptor write, it holds a pointer to this. If it just held one of these, then that'd work better for me. But anyway, it holds a pointer to this. So I need just something that can own the lifetime of that pointer for this function. And so the list actually does work in this case. Yep, so push back. Buffer, descriptor info is back. Descriptor count 1. Yeah, that's good. Type to usage. Yeah, I'm actually not going to do this right. This part here. This is for like creating a buffer if it doesn't exist. I don't actually want to do this right now because there's an issue here about it's just like a weird thing about how the memory allocator library works is that if I call create buffer, it doesn't actually make the Vulkan buffer until I try to allocate some memory for it. And so this caused like weird validation errors because you can like try to because it'll still like use the buffer down here, but this is like VK null handle or something. So I'm actually just going to say that this isn't supported yet and just throw an error. Creating buffers in descriptor date is unsupported. Okay. Let's see. All right. Yeah, so I'll leave that alone for now. And yeah, if you use descriptor buffers, otherwise set the buffer stuff. And then for sampler sampled image, so memory manager. Yeah, I need memory manager. Okay. And then I just need to fix the prototype here. Standard shared pointer pipeline pipeline. Yeah, just add this. There we go. And then I don't actually need vector then. Okay. So, yeah. So I'm still not actually doing anything with only rebinding the needed sets because even though I am doing this register invalid thing, it's just not, actually just comment this out so I'm not using that. Yeah, the problem is in between these, like in different shaders, I can just be overriding the descriptors that I've already bound. And so it's just like, I'm probably going to have to rebind everything anyway. Now, like if I have like a more complex, like deferred rendering setup, then it's probably gonna be a little different. But for now, this is fine and it's fast enough. Yeah. So descriptor buffer infos. Okay. And now when I call update, I need to pass the pipeline. So, yeah. I mean, the way to do this, the way I can do this right now, is in here instead of pipeline update descriptors, this is descriptor manager updates pipeline. There we go. Yeah, and so what this little lambda function is here, this is, I have this built into my render graph where if I want to, I can run a function before the Vulkan, the actual Vulkan command runs. And so like this is helpful for things like if I want to run a pipeline update before I go and I bind the pipeline, then this works pretty well. So let's go back here. So really I haven't changed anything. All I've done is abstract out this update function to a new class. Okay. Let me see if this even works or if I like crash my GPU or something. Okay, well it doesn't compile, so that's not a great sign. No such file or directory. Oh, right. That's why. It's because, I mean, technically I'm not using it right now anyway, but this needs to be like /Vulkan. Yeah, that's why I was having the problem. Okay. So I'm about to run this and it might crash my GPU. If it does, I will be back in like a minute, maybe. I just have to reboot my computer probably. So I'm going to run this. Hopefully I don't crash. Hey, I didn't crash. Great. Yep, so everything's working. So modified. Yeah, it happened a few times the other day with when Mochu P was here. I kept crashing because I was it was actually this little if statement here. I had this as like if instead of if not. Isn't there a keyboard shortcut to reboot your graphics driver? I don't know. Maybe. Like I could probably set something up, which yeah, I mean, given how many times I've like crashed my GPU, that'd probably be better. Because what I was doing is just like rebooting my whole computer. Um, yeah, that'd probably be a good idea to set something like that up. But anyway, what I done wrong is I had this as like if use descriptor buffers, and I have descriptor buffers turned off. Um, and so, but this actually needs to be if not. And so what was happening is I was never actually running this update descriptor sets. And so I was never writing the descriptors onto the GPU. And so when I go in like the vertex shader and I try to use the descriptors here, I was basically like dereferencing a null pointer on the GPU, and that was crashing everything. Um, and so fix that. But anyway, so this is all working now. Yeah, let's add all this commit descriptor manager class. Okay, so at least now, like when I have multiple pipelines, I can just update the descriptors for that pipeline, which is good. Um, Win Control Shift B. Okay. Yeah, I'm not sure. I'm on Linux using KDE, so I don't know if that actually works for me. But yeah, that's like I know I can definitely set up something with like I can just like kill uh X11, the display server, and that'll totally shut off the GPU driver, and then I can just start it back up. So I know that'll work, but I don't know. Yeah, I don't know if that works. Yeah, Windows thing. Yeah. Yeah. So all that's fine there, and then what was I doing this for? Sorry, I'm getting a bit sidetracked. So I have like all my to-do list on my phone. So right. So what I actually wanted was maybe handling these descriptor counts a little better. Yeah, because I want to be able to just like add a whole bunch of uh add like a whole bunch of images, and if this descriptor counts it big enough, then I want to make it bigger. So yeah, and so in order to do that, I have to recreate the pipeline whenever I um, recreate these pipelines, which is really annoying. Hmm. Yeah, I have to recreate a lot of stuff actually, because it's not just a pipeline. Like I have this whole thing, like everything that's been like depending on the pipeline will actually have to change in Linux. Yeah. I can. I'm sure I can set something up. I just need to actually do it. Hmm. So do I actually want to do this right now? Hmm. I don't think I actually want to go through like trying to recreate the pipeline stuff right now. Um, because what I can do in the meantime is just set this descriptor count to like 100 for each of these, and then just give me enough pool space up here. So just set this like 101 or something. Um, and that should give me enough just to get like other textures working, because I want to get like other models and things in. Yep, so that works just fine. Increase texture limits. Okay. So what I actually want to do is work on like normal maps and other models and things like that. So this is like my I don't know if you know anything about GLTF files, but it's just kind of model files. and this is where I'm loading some of the stuff from it. Okay, so fix me, move this check, fix me default sample. Oh, right, I also want to get bitmaps working. Fix me, update texture index when a texture is deleted. Yeah, I need to do that too. And then handle normal textures. Yep. Okay. So let's start with this one. This seems the easiest. So yeah, I'm like checking if base color texture has value. Right, this is PBR data. Yeah, so I'm doing like the same thing. Right, and so then I'm getting the texture. Yeah, the text coord index. Okay, so this is loading up the texture coordinates. Okay. Yeah, so this is loading up the texture coordinates for the vertex shader into the actual vertex is where I'm storing the texture coordinates. Okay. Yeah. That's fine. So if base color texture, yeah, and if it has a texture, it's going to have texture coordinates. So yeah, and then where am I doing material PBR data? Yeah, texture index, model asset textures. Optional base color texture. Material PBR data. Okay, I see what I'm doing. Yep. So I just need to move this stuff up here, right here. So this is load text coords into vertex to vertices. And then this is load sampler for texture, load texture. There we go. And then, yeah, I can get rid of this. And then instead of here, this should be gltf texture.text coord index. No, that's not right. Is it this? Yeah, I think it's like this. Dot text coordinates. There we go. Yep, so load the texture coordinates. Okay. Let's see if that works. Hey, there we go. So that works. Load text coords with texture. Okay. And then now, if I want to handle normal textures, first I want to load something that actually has normals in it. And so, yeah, I have box. So there's simple animation, simple materials, meshes. Yeah, it's water bottle GLB file. I know this one has normal map, right? I'm like 90% sure. Let me see, GLTF sample models. Yeah, and so if you are making a game engine, I'd recommend looking at these GLTF sample assets because there's just a lot of like decent quality assets to go and test on and try to get working. Anyway, and here I'm looking for water bottle, and I'm just trying to look and see. Yeah, so it has a normal map, occlusion, metallic roughness. Yeah, so the normal map is, I don't know, something like this. Yeah, so it has a whole bunch of like little emblems or something on it. So then let me go in here and load this up. So, yep. And eventually what I want to, so this is how I'm currently like loading models. Eventually, I want to be able to like pull this from a JSON file or something, so I don't have to recompile every time I want to do models. I've been working on more important things. Anyway, water bottle model. This should be, was this water bottle GLB? Yep. Okay, and then simple texture ID, water bottle ID. That should be water bottle model. And then object water bottle object is this. No, I should probably just I don't really know why I'm not doing this, but yeah, so here, like, I'm doing add object and add, oh yeah, okay, I see. Yeah, add object is returning the object ID, and then yeah, I have to call get object, but yeah, like I could return both, but this is fine. Anyway, also, let me move this stuff here. There we go. That's a little more clear. There we go. Water bottle object. Let me set your position to be 0, -50 or something. Let's see what that looks like. And this shouldn't crash me. I'd be surprised if like my GPU driver crashed when I run this, but just in case, just let you know that if I do leave in a second, I am going to stay here. I'll be back in like a minute. Okay, just crash this. Okay, to do buffer view images. All right, that's fine. So let's see. So yeah, this is in here. I just need to actually load the textures from this file. So buffer view. All right, buffer view sources. Let's see. Bytestride, export it. Yep, that's fine. So let me pull up the fast GLTF docs. So I have a data source, right? And this data source is a buffer view. And how do I actually want to load this? Because this is... Okay, so buffer view sources. Oh, I can make this a little bigger. Sorry about that. Yeah, so I'm just trying to load the texture data from the GLB file right now. And I don't have one of the ways that... So one of the ways you can store like texture data is to embed it in the file. And I don't support that yet, but I'm adding support right now. So let me just uncomment this stuff because I probably need it. So buffer view is asset buffer views a buffer view index. Okay, that makes sense. And then asset buffers buffer view index dot data is another data source. Okay, but then this one is probably buffers. Yeah, that's where it gets a little confusing, but I'm pretty sure this has to be an array. Or a vector at least. Probably just an array. Since it is a buffer. Let me see. There's also a really good GLTF spec image. It's like a good image somewhere that shows everything about GLTF files. Here we go. Make it a little bigger. So yeah, buffers, buffer view, successors. So yeah, buffers. Okay, and then a buffer can have a URI, or it can have each of the buffers using a URI. Does it have to refer to binary data file? I don't think so. Is the source one block of raw data? Yeah, so I get a buffer view. Yeah, and this is pointing into a buffer. And then, okay. Yeah, so this can either be so it can be a URI, or it can be something else, but I'm pretty sure it's just going to be an array. Oh, yeah, see ya. Yeah, it should be on tomorrow as well, if you want to jump back in. Anyway, so I got this data, and I want to see, yeah, if holds alternative. Yep, see ya. Thanks for following. GLTF sources. I think I just want an array for now. Else, let's move this here. Buffer view, image source plus toString. This needs to be the alternative ID. How do I get this again? I think it's just like .index or something. This dot index. No, I thought it was just dot index. If holds alternative. Okay, missing that. Yeah, that's fine. That is dot index. Okay. Now, let's see. Yeah, so if this is an array, then what I want to do is say fast GLTF. Yeah, sources array buffer const reference buffer data source. Yeah, standard get GLTF sources array. Okay. And buffer bytes. Yep, that's what I want. Buffer bytes data. Okay. So it's like the same thing that's down here. Actually, it's exactly the same. Yep. I could definitely clean this code up some as well, since I'm like it's kind of recursive in a way. It's not really, but like there's buffer view here, and the buffer view can point to an array. So I probably just need like load array or something. I'm not sure, because it's a little redundant. Buffer pixels. Yeah, and then this stuff can go away. Else if buffer view, and then if the buffer view points to an array, and load that. And oh yeah, I also need like the offset and the stride and all that. Buffer.bytes. Yeah, no, it's not buffer bytes. It's It's like buffer view. Buffer view dot byte length. Yes. And then this is data. Is this a... I don't know what this is. Anyway, this should be buffer view dot offset. There we go. That should work. Offset length. Yeah, no, I don't support stride since STBI doesn't support that, and I have to like copy it into a new buffer first, which is fine, but not going to support stride right now. Okay, let's see what this does. Okay, it crashed. I don't know why. Well, I mean, it's probably something to do with this. Yeah, byte length, byte offset, bytes data. If, else, if here, if holds alternative, otherwise, throw a runtime error. Yeah. So I guess it had a problem. Like it is an array. Buffer array. Done loading buffer array. Because it should work. Buffer array done loading, buffer array done loading, buffer array done loading. Okay, so it's somewhere else. Well, that's annoying. But run. Yeah, there we go. Free. STBI image free. Okay. Wait, what? That doesn't make any sense. Why was free even being called in the first place? Textures dot in place back. Why is this calling free? Okay. Well, that needs to be texture pointers. Because these, yeah, I think I need to mark textures like non-copyable or something. Yeah, but this needs to be, yeah, these can be texture pointers. It'll same for the sampler. And so it's not in place back, but this is going to be like push back, new texture, like that. Same thing with this. Push back, new sampler. There we go. Yeah, new texture, new sampler. And then something else. I'm sure that broke things somewhere. Model, get texture. Yeah, like there's no way. Oh, because get texture. Yeah, get texture is returning a pointer now. Yep. You're returning a const pointer. And yep, so now this is broken. So then your image info like that. Your image info. Yeah, that's fine, I guess. Okay, that should be better now. Oh, I need to delete these. Do I have a destructor for model? No, I don't. Well, I do now. Texture in textures. same thing for sampler. For sampler and samplers, delete sampler. There we go. Okay, so should work now. Hey, there we go. The water bottle working? It's really small. It's also upside down. Hold on. But it looked like it was working. So let's get rid of those. And then let's... Okay, so it doesn't actually need to be at -5. I'll put you at like -2, but then I want to scale you up by like 10 times. Scale 10, 10, maybe 5. 5, 5, 5. And then I also want to flip it. Rotation Euler. I think it's 0, 180. There we go. Okay, so is this actually working, or... Well, yeah, I mean, it's loaded in. But I don't have the actual, like... Yeah, I don't have, like, any depth from the normal map. Okay. Or... Right? Yeah. I'm not even loading the normal map in the fragment shader yet. Yeah, so it's definitely not working. But I was able to load all the textures, which is great. Yep. Good. Now I just have to actually put those textures into the shader and the model and all of that. So fix me, handle normal textures and normal coordinates. So, yeah, so normal here. Remember, texture coordinates were always really confusing with GLTF. Like, you can have like 2 or 3 different sets of them. But like it's just really strange how it works. Like, not just between, like you can have like 2 different sets of texture coordinates for like the base texture, which doesn't make any sense. So I don't know. There's something like kind of confusing about it. So accessors, materials. Yeah, okay. So here's texture coordinate. Yes, that's what texture coordinate I'm using. So scale will be applied to these normals. First, to a texture that contains tangent space normal information. I don't even think I had scale before. Index. And what is index? Is this the texture itself? Yeah, this is where it gets like kind of confusing. The texture references the material always contain the index of the texture. They may also contain the texture index. So yeah, they may also contain text chord set index, but it might not. And then, yeah, text chord 1 is 5. But what is 5? Contain text chord set index. Let me pull up the actual GLTF docs. What is it? I guess just concepts. Texture data, textures, source, sampler, Where's texture coordinates? Normal, tune space, normal texture, XYZ components. Should not contain an alpha channel, as it's not used anyway. Okay. So one thing though, these normal textures, so right now, where is it? I'm always using 4 channels, but I only need 2 or 3 channels. Yeah. And so really, I don't want to just like set it if it's a normal. What I want to do, hey, scale 1 to 1000, how hard is Vulkan? I'd say the hard part isn't like Vulkan itself. Vulkan itself is just like mostly boilerplate. The hard part is actually if you want to like make things very dynamic, especially with like what I'm doing with indirect rendering, because you basically have to manage a whole bunch of memory yourself. So like usually like in OpenGL or something, and you can do this in Vulkan as well. You can have like 1 draw call per material or something, and so what you do, you like load the material, and then you do a draw call, and then you actually send that to the GPU and you tell it to do it, and then you load another material, and then you tell GPU do another draw call, or at least 1 draw call per like model that you're using the material for, and you go and send that GPU and you do that like 1 at a time. But with Vulkan, if you want to get it fast, you can send like all that stuff to the GPU all at once. But it's a whole lot more complicated to manage all that stuff yourself, because you have to be like you have to manage all that GPU memory yourself. And so that's a big part of what actually makes Vulkan difficult. And then, yeah, there's all the boilerplate stuff, but all the boilerplate isn't really too bad. There's 2 really good websites. It's Vulkan Tutorial and vkguide.dev. Both of these will kind of get you through the boilerplate and all the basic abstractions. You have to write allocators for GPU memory as well. Yes, well, sort of. I'm using the Vulkan memory allocator library, and so that makes things a little simpler. But like right here, this is like some complicated, this is like a memory allocator library I have here. And so Vulkan memory allocator is handling all of like the like, I guess like Vulkan specific stuff about, oh, what type of buffer do I need to be using for these type of flags and on this GPU and things like that, like all the kind of tedious stuff. And then on top of that, I just have my own memory allocator library. And so this has support for stuff like, okay, if I want to have like a vector on the GPU, how do I actually do that? And that's what this contiguous fixed allocator is here, is basically just a vector. And then I have like a fixed allocator, which this is more like, not exactly like a linked list. It's more like a vector of pointers. Something like that. It's not quite right, but and then, yeah, like a linear allocator is just like allocate me like one big chunk of memory on the GPU and let me do things with it. And so like getting all this working was pretty complicated, especially if you want to get this like working fast with multi-threading. And so like, I guess with Vulkan, if you just want to make a game, then you're probably better off going with like an actual game engine first. But if you really want to like get deep in the weeds on writing your own game engine, then yeah, Vulkan's great. You can do basically anything you want with it. Yeah, but even just to have something, like if you do Vulkan without indirect rendering, things get a lot simpler. So rawest form of memory allocation Vulkan. Is there Malik? Kind of. Well, so there's it's probably more close to what you're thinking with OpenGL, but there is like VK create buffer, right? And this is like the lowest you're going to go with allocating a GPU buffer. And so you pass it this buffer create info, and this just tells you like the size, the usage, and all that. And so if you want to have like basically malloc, so what you can do is you can create a buffer, and you can have and so it takes all these buffer usage flags and show these. Or no, not those. The buffer. Where is it? Wait, no, it's memory properties. That's what it is. Buffer create info. Buffer usage. Where's the memory properties? Flags. I don't know. Anyway, somewhere there's like Vulkan memory properties. And so what you can do there is you can say, okay, I want a GPU that's local, or I want a buffer that's local to the GPU, so like in VRAM, and then I want I want it to be host visible, and then what you can do is map that, and so you can just have like a pointer that goes straight to GPU memory. So if I show you my allocation library, that's what I'm doing right here. So I'm uploading stuff to the GPU. I'm literally just using memcopy because I have this pointer that's just some VRAM that I can write to. And so, and there is something to note if you're doing it like this, is this only works really well if you have like a resizable PCIe address space or above 4G decoding or whatever you want to call it, because otherwise the device local host visible space is limited to 256 megabytes, I think. But with the resizable address space, you can you can see all the VRAM. So otherwise, if you're on like, I don't know, like mobile or something, or like some old hardware that you're trying to run Vulkan on, and it doesn't have support for resizable bus address space, then you have to like use staging buffers. So like you want to upload some textures. Well, now you have to like make a staging buffer that actually has like host visible device local memory on it. And then that, I guess like you'd be limited to a max size of like 256 megabytes. And then you copy stuff into the staging buffer just like this with the pointer. And then you issue like a copy function, a copy command on the GPU to copy from your staging buffer into your actual buffer. And so that's just like a few extra steps. It's not that bad, but yeah, just having like resizable bus address space, then you can just get a straight pointer onto the GPU. That's great. Yeah, and so Vulkan memory allocator handles like some of the stuff for me, right? So I have like VMA map memory, but even doing that in Vulkan isn't difficult. Vulkan map memory, like you mentioned, deferred running. Oh, I'd say learn OpenGL is great. Even though like it says OpenGL, but it's just mostly like graphics stuff. So yeah, like there's some stuff in here about getting started with OpenGL, and this like getting started is kind of the equivalent of like the Vulkan tutorial or vkguide.dev. But then after that, like all the lighting code, and like all this stuff, you can do the same stuff in Vulkan. And so like if you want to learn like the shader and graphic stuff, it's probably easier to be using OpenGL, just for learning, just so you have to, because OpenGL takes care of a lot of this stuff for you. But with Vulkan, you have to do everything yourself. And so it's easier with OpenGL to like play around with this stuff. But in any case, I recommend this website a lot for learning like lighting. And here's like physically based rendering. I know they have deferred rendering in here somewhere. Yeah, deferred shading. Here it is. Yep. So recommend this website a lot. So anyway, what was I working on? kind of lost track of what I was working on. Oh yeah, so right now I'm trying to get normal maps working. Yeah. So I'm trying to get normal maps working, and I just managed to load. So there's this water bottle sample texture, and or sample model I got from the GLTF sample assets GitHub, and then so the normal map, it like adds a little bit of depth to different parts of it. So I don't know how well this actually shows up on stream, but like there's like this little symbol down here, but if you see, it's like actually flat. But with a normal map, it could have like some depth, a little bit of depth to it. And so right now, I'm trying to actually load in normal maps. And so I just got the water bottle to show up with like the textures. Really strong Linux. Right now, I'm using NixOS with KDE. I would not recommend NixOS if you're like just getting started with Linux. Fedora works pretty well. So does Ubuntu and Mint and all that stuff. I used Arch for quite a while. And Arch is really good for actually learning Linux and for using day to day. But like if you really want to learn Linux stuff, I'd recommend just like at least start up like a VM and then try to put Arch on it and just like go through the whole Arch Wiki install guide. So where is it? Installation, yeah. Or no, this is just for NVMe. Where's just like the installation guide. So if you go through this like Arch installation guide on like a virtual machine or something, you'll learn like quite a lot. That won't break if you don't update your system for a month. Yeah, so I probably just stick with like Fedora because that's based on Red Hat. It's kind of, I think Fedora, it's like the free consumer version of Red Hat Enterprise Linux. And so you'll probably have like the least amount of problems with that. You can also try like Debian, but Debian has other issues where it's like a lot of time it can be so out of date. You also have issues with that. Ubuntu works great as well. So probably like Ubuntu or Fedora. And you won't have too many problems. So fix me handle normal textures. And so if I go to the, where's this? Yeah, GLTF spec page. So normal tangent space, normal texture. Yeah, so XYZ components of normal vector and tangent space. Right, and so normal textures don't contain an alpha channel. And so I'm loading these for my images. I'm loading up these channels, but I'm manually setting the format here. I'm forcing it to be 4 channels. And so I want to change this around to be able to take in a number of channels and then output a format. But I don't know if I want to put that straight into image. I think what I'd like to do, if I go up here, I can say this can return a VK format, and I'm going to call this channels to format. This is going to take in a uint channels and return. Yeah, this is just like switch channels case 3 return whatever, case 4 return VK format, this one. Let's just say sRGB. And that just leave it alone. And that should be VK format R8G8. B8 U norm? I guess so. Oh, let me look up all the formats. So I just want like 3 channels. I don't know what the difference is with unorm and snorm, uint. sint. Okay, so probably uint is what I want. R8, G8, B8, uint. B8, yeah, RGB. Yeah, there's a lot of these. But yeah, this is the one I want. Uint. There we go. And then default time error unsupported. Oh, right. Let me make this a little bigger. Number of channels. String channels. There we go. So now it's a load pixels. So yeah, and here I want to pass in number of texture channels. Actually, I should already have that. Yeah, I just have text channels, so that's good. So I'm gonna say channels to format text channels. There we go. That should work. So now I can have so now it'll actually load in the normal textures correctly as RGB values and not RGBA. Should not contain alpha channels. Okay, normal textures should not contain blue values less than or equal to 0.5. Okay. Texture binding may contain a scale value that linearly scales x and y. Normal vectors must be normalized. Yep. When scaling is used, vector normalization happens after scaling. Okay. But I don't think for now the water bottle doesn't do scaling. Let's see. Yeah, so this is all I have to deal with is normal texture, which is index 2. So you'd go to textures, you'd go here, which would be source 2, which means, yeah, this URI here. And so it would just load in the image or something. Okay. So then I don't have to worry about scale, but I do want to, if it has a scale, I do want an error. And just so I know, like, hey, the scale's broken. So handle normal texture. So okay, so material, right, you contain a material and this is loading the base color factor. Yeah, okay, and then this is loading the base color texture here. So let's see, let's load base texture and then load normal map. So if material data dot, I guess it's just normal index, dot minus, oh, it's just a uint. Oh, right, this is, yeah, this isn't right. This is where do I need to look? I need to look material dot normal texture, material. Yes, that's like PBR metallic roughness, right? But this is just a normal texture. So packed normal metallic. Yeah, I'm not going to deal with that. Material normal texture has value. Otherwise, I want to use the default normal texture. So if you have a normal texture, then I want to get the normal texture like this. Texture index. Yeah, so this is material dot normal texture dot value. GLTF texture. That's fine. And then what does that say? So name, image index, sampler index. So can the, yeah, because that's just pointing to a texture. And so I need to load the sampler as well. Right? Yeah, so I can have a scale and a set of texture coordinates with it. Okay. So but I don't support either one of those. All right. Oh, and he left. Okay. Anyway. So let's see. GLTF texture. I just want to look at the image index. Well, I need image and sampler. So, maybe. Right, so right now I only support one sampler, which is not great. Fix me, support multiple samplers. Fix me, custom sampler, custom scale. Okay. I just want image index. Yeah, so texture, image index. And it has to have a value because it doesn't make any sense for you to not have a value. Yeah, and I just want to get the texture. So model get texture. Yeah, it's fine. And then instead of base textures, this is normal textures. No. Normal textures. And then I want to say texture equals texture. Yep. Here we go. And then normal index. Okay, so that should, yeah, I think that'll do it. Because the descriptor manager should take care of all this for me. Yeah. Since you should just do this for every binding layout and all that. Great. So then in here, texture 2D. So then let's say texture 2D normal textures. How am I doing the normal? Get normal from map. So tangent normal equals normal scale. I do have normal scale. Okay. Times texture, samplers, texture coordinates, RGB, world pause. Whole bunch of stuff. Okay. And what am I doing with the normal? Yeah, there's metallic roughness. Yeah, and is get normal from map. What am I doing with this? A lot of stuff. Okay. Well, I should at least be able to get this working. Get normal from map, right? And then return normal. What? That doesn't make any sense. If normal index equals 0, return normal. What? How did this ever work in the first place? Get normal from map. this is the wrong one. Yeah. Yeah, set 0 binding to normals. Normal textures. Okay, I do have an invec3 normal. Okay. So how does that work? Right, so I'm inputting a normal from the vertex. Right, because there's... Yeah, so the primitive, yeah, it can have its own normal, like texture coordinates. And then you can also have a normal from the normal map. Right, and so this is, so is this like buffer view 1 or something? Yeah. Okay. That's a little confusing. Like, yeah, I don't get why you'd have a normal map and a normal. It just, I don't know. Seems very redundant and confusing. So, geometry, meshes, skins. Yeah, so attributes normal. Meshes are primitives, correspond to draw calls. So normal is normalized normals. Yeah. So then why would it have... Okay. Yeah, I guess that's like the base normals. That's just like the like perpendicular to the vertex or something, but like you just calculate that from the vertex. So why is this a thing? I don't know. But it's in here, so GLTF normal versus normal map. Yeah, it's a little weird. But I do need it to get everything working, right? And then out normal scale. I'm getting normal scale from the material. Okay. Okay, so I need a bit more work to get this working. Do I? Like, I won't have the normals it's supposed to have, but... Does this have... Yeah, it does have, like, space. It's like an extra model, but... Yeah. So... Text chords, temp vertices, text chord. So... Yeah, so primitives attribute, so normal, position, tangent. So positions, get positions. What is this? So return, accessor, position, text chord. Okay. Right, because these are accessors, right? It's an index of an accessor that contains the data. Okay. So, yeah. I can say get normals. And then load accessor, find attribute normal. But I only want to do this if it exists. Right, like I get positions. And I'm not calling get text chords, I don't think. Or yes, I am. Right here. If yeah, text word index. Get normals. Is it guaranteed to have a normal? Normal. Position accessor. But what I don't know is, like, is everything supposed to have normals? The name of the property depends on enumerated value. Primitives. Accessor bounds. Yeah. If material is undefined, yeah, default material. But normal. Does it have to have that? Let me look at the sample models. I know that has it. Does the box have normals? Because the box is like simple as it gets. So it does have normals. Okay. Then I'm going. Okay, but it doesn't have texture coordinates. Which is weird. Okay. But, well, yeah, because it doesn't have a texture, so it doesn't have texture coordinates. So that actually makes sense. Yeah, and text coord selector. So this actually does make sense. So get normals. So this should always have something. So that's good. So yeah, get texture. Or, no. Where am I doing get? Okay, here it is. It's under this. Get normals. There we go. Find attribute normal, return load accessor. Yeah, okay, that's fine. So now text coords. So really, I just want to go up here. Get positions dot size. Pause equals positions of I. Okay, so then I just want to say vector of vec3 normals equals get normals. And then tmp vertices of I dot normal equals normals of I. There we go. And then in the vertex shader, yeah, so I'm already reading it in, so that's fine. And then I'm already outputting it here to normal out. Okay. So location 8. Layout location 8 in, is this flat? I don't think so. Yeah, in vec3 normal. Yeah, and then this is get normal from map. If normal index is 0, yeah, don't do any of this, just return normal. That's fine. Turn normalized, TBN, yeah, all this stuff. Normals of normal index, right? So I need normal index. Sampler index. Frag text coord. Okay, and then I do need normal scale, and then this is tangent normal. And I also need world position. Yeah, I don't remember how any of this code works. Put that there. Get normal from map if normal index is 0. Turn normal. Otherwise, do all this. Scale, world position. Okay. So now I do need some more stuff from the fragment shader because I need world pause. So this is an in vec3 world pause. And then I need normal index. Actually, I should pull it from the fragment shader. Yeah, flat uint That all looks good. 1, 2, 3, 4. I don't know if it cares that there's a gap there. Just grab these anyway. I will need them eventually. Yeah, metallic roughness and ambient occlusion. Yep. No, I'm not using these currently. Yeah, that's fine. Because those are just 0 and I'm not doing anything with them. So it shouldn't be a problem. Row position. Okay. So I need the normal scale. So I also need that. Where's that coming from? Normal scale. It's after cam pause. Why am I using cam pause? That's for lighting things, I think. NV. Yeah. That's, I guess. Yeah, just copy all this stuff. I'm going to need it all anyway. Cam pause, normal scale, metallic factor, roughness factor, occlusion strength. And then metallic roughnesses and AOs. Metallic roughness textures. AO textures. Go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 0, 1, 2, 3, 4. Cool. 13, 4. Yep. All right. So got everything set up here. And then I still need. What's world pause? Is that? Yeah, that's fine then. Normal is normal. Cam pause. Yeah, everything's fine here. Don't have to worry about any of that. Okay. So, but I do need to figure out the normal scale. And so that, where does that go? Normal scale goes in material data. Okay. So then let's load up image. No, not the image. Model. So normal textures, generate handle normal textures and normal coordinates. All right, I want to load the scale. And so that's, yeah, that is material data. So where does the scale sit? Normal. So it is in the normal texture, right? Materials, additional textures, normal. Yeah, so the normal texture contains the scale, but it's only going to have one normal texture, so that's fine. So there's the texture, gltf texture dot. Sets textures. Maybe it's just material dot normal texture dot value dot scale. There we go. Transform. Texture index, export index. All right, here's going to be a scale. And that can say material data dot normal scale equals this. Now, is this guaranteed to exist? Yes. And by default, it's 1. So that's good. Okay. And yes, so that's, yeah, load the normal texture, load the normal scale. Is that everything? Normal index, tangent normal scale. Okay, now I need to actually do something with this. So let's go to Learn OpenGL and remember how normal maps work. Yep. So to get normal mapping to work, we're going to use per fragment normal, 2D texture, sample it. All normal vectors are geometric entities, and textures generally used for color information. Storing normal vectors in a texture may not be immediately obvious. If you think about color vectors in a texture, they are represented as a 3D vector. RGB, we can similarly store normal vectors X, Y, Z in their respective color components. Right, and also, yeah, there is no transparency. So, like, right, like blue pixel, right? This should actually have no alpha channel. So, I'm just gonna put something in here about that. Or no, that should go base textures. Well, actually, it's fine because I'm not using a normal map if I don't have one. But that's if normal index equals 0, yeah, but what if I actually have something stored at 0? That's not great. Because, yeah, this is going to get, yeah, this is going to get stored at 0. Like, I guess I can just put something at 0. Like, this is really bad. Really bad, but, I guess it does technically work. Push back, default normal textures. Fix me. Bad solution. The shader to just skip the normal map if using the default, using 0 for the normal index. Also, normal maps have no alpha channel, but the blue pixel PNG does have it. Okay. At least commented it. And then image default normal textures. And I could probably just combine these two, default base textures, default normal textures, but I'll keep it separate for now. It's fine. Okay. So, what was I doing? Yeah, model. So custom sampler, that's fine. I can do that later. Yeah, mip maps. Not doing mip maps yet. Support multiple samplers. Yep. Okay. I think that's. Yep. So that fixed that, and now back to this. Right. So RGB normal equals normal. Okay, so this is just transferring it from -1 to 1, and now 0 to 1. Okay. That's fine. Bluish tint. Color. Deviations in color. Percent normal vector slightly offset. Giving sense of depth in the texture. Yeah. Simple plane. Texture. Yeah, so obtain it from normal map. Transform it. I would assume, well, I don't know. Are these actually in the right? Is in the right format? Normal. Okay, so XYZ components should not contain alpha channel. After dequantization should be mapped as follows. After dequantization. Red 0 to 1 to X, -1 to 1, green 0 to 1, Y. It looks like this is getting mapped anyway. So whatever. Seems to be fine. Yeah, it's fine. Okay. Yeah, so I'm doing all this. Yeah, so normals only make sense within lighting. And so I have to have lighting if I want normal texture. Okay. Manual calculation of tangents and bitangents. Oh man. Yeah. Actually, can I do lighting now? All right, so there's like roughness and stuff. Right, yeah, and then here's the lights. Like I could just do blend Fong lighting, which is fine. Yeah, this is all the TBN stuff. So, lighting, basic lighting. Yeah. So how to do normal maps with blend Fong? Then use the sample normal vectors for the lighting calculations. Right. So, okay, yeah, blend Fong probably just has lighting. Like, it probably uses the normal to figure out the light. Yeah. Okay. Yeah, normal vectors are it. So instead of using this or whatever, I just use that. Yeah, so light direction is normalize. Yeah, so norm, diffuse frag color. Yeah, specular lighting. Yeah, no, I'm not doing specular reflections. I just want like super simple lighting to make sure normal vectors are actually working. Okay. Frag position, normal, GL position. Norm equals normalize normal, light direction. So light position. So I need to store, yeah, uniform vec 3. Okay. So I just need to store some light position. And then light direction, dot product, max, yep. Diffuse is diffuse times light color, which can just be white. Frag color is ambient plus diffuse times object color. It's diffuse. Where are you getting ambient from? I guess it doesn't matter. Yeah. Doesn't matter. Okay, so this is pretty simple. Let's go back here. So I've got my normal. Hold on. Yeah, I guess it won't. Maybe I can't get it to show up. There we go. I don't know how readable all of this is. Hopefully it's decent. Oh, yeah. There we go. So, geo position, frag pause, normal, frag pause. Yep. Light position. Okay. So I'm going to start up here and I'm going to say vec3 light pause equals 0, 0, 0. That's fine. And then the ambient plus diffuse. So then we're going to say vec3 diffuse. So this is base color factor times texture color. Right. Oh, this actually needs to be a vec4. Right, so this is the object color. And then this is the diffuse times this. There we go. And then, yeah. So vec3 norm equals get normal from map. Here we go. And this is already normalized. Or I would think this. Actually, I'm pretty sure I should be doing normal scale times normal and then renormalizing it. Something like this. I think that's what it's supposed to be. If I go to GLTF, somewhere it talks about this. Right, but no, but it only has a normal scale if it has a normal texture. Yeah, so that's fine then. Right. Anyway, so there's my normal. And then vec3 lighter equals normalize. We have light position minus, should have frag pause somewhere. World pause, is that what it is? Equals model times a position is a pause. Whatever, it's that. It's GL position. Frag pause. Yeah. So world position, yeah, it should just be world position. Yes, vec3 avert pause, which is that. Yep, that makes sense. Okay. So it's not frag pause, it's world pause. And then diffuse times light color. Yep. So then float. Oh, okay. Well, I just have white anyway, so float diffuse. Yeah, that makes sense. Okay, yep. Yeah, because I was thinking earlier, like, if I'm just adding diffuse to it or whatever, yeah, if I'm like multiplying by diffuse. Yeah, okay, that makes sense, right? Because I don't care about like the if there's any ambient color in the object. Now it's all well, I could add ambient lighting, but diffuse is what really matters. Anyway, not important. Yeah, so light direction. It's normalized light pause minus world pause. And then float diff equals max dot norm with light direction or 0. And then, yeah, and I don't have a light color. So, yeah, so I'm just going to return this. Because it's white, and so it doesn't matter. Yeah. Well, no, I do need return vec3. Yep. 3. Yeah, let's do it like this. One, 1, 1. Is that what I want? No, I want like 255, 255, 255. Or at least 32-bit ints. Or how do I just get the max? Whatever. Yeah, vec3. What? I would assume this is 32-bit ints. Single, okay, yeah. Floats, yeah. Vector single precision floating point numbers. Right. And so if I want I just want white. Well, yeah, it's all just, like, it's just like 111, that's fine. Then that's just the intensity or something. Yes, okay. I wonder what, yeah, ambient strength. Just wonder what he's using for light color, but anyway. So out color equals diffuse times base color factor times texture color. Yep. So right here, I want to return diff times light color, and then that's just diffuse. And ambient strength is 0.1 times light color. What is he setting light color to? Just 111. Okay. Sure. Let's just see how this is. Yeah, I don't know if these are these between 0 and 1. I hope so. That'll make things. Yeah. It's all got to be between 0 and 1. I think that makes things really easy. Yeah. They're whatever 32-bit floats. Yeah, this should be fine. Whatever. Fuse times that. Yeah, and then I might add ambient to here. Let's see. Hopefully this doesn't crash me. I don't think it will, but I don't know. Unsupported number of channels, 2. That's probably the texture coordinate, I would guess. And what does have 2 channels? What has 2 channels? Image. New image. I mean, sure, whatever. Not entirely sure what has 2 channels, but R8, G8, uint. I mean, maybe it's like STBI compressing things. I don't know why I do that though. Whatever. Guess I can do 1 channel as well. R8 S, sure. Is there not an R8 uint? There is. Okay, you just didn't want to tell me. Oop.